Considerations about the type of propulsion engine or motor you should choose when refitting or new installing a propulsion system in your displacement hull type vessel. It is a regular procedure to include a greater reserve capacity when choosing the size of an internal combustion engine, due to the fact that the torque of the combustion engine is dependent on the RPM, whereas an electric motor develops the torque independent from the RPM. This is the reason why most of the displacement hull type vessels are quite overpowered. Studies show that the power need of 2.5 kW per ton displacement suffice to achieve the hull speed. 2 kW per ton are sufficient to reach 95% of the hull speed, and 20% of the power, aka 0.5%, suffices to achieve 70% of the hull speed with no problem. 100% hull speed is practically seldom used, even in the case of overpowered vessels, as everything shakes and vibrates in the vessel, but it will run smooth and easy when cruising at 80% or below max hull speed. Also, the fuel consumption would be increased by 4 to 5 times in order to gain a mere 1 to 1.4 knots of speed. Since the thrust developed by an electric motor in the partial load range is up to 300% higher than by a conventional combustion engine of equal rated power. This shows clearly why it makes sense to choose a bigger combustion engine, but it makes no sense at all to install a higher power rated electric motor. A real-world test performed by an independent testing facility, with 2 equal 50-feet yachts, both with approximately 14.5 tons displacement, one powered with a 75 HP aka 55 kilowatts diesel engine, and the other one with a 35 kilowatts electric motor, resulted in the following findings. The vessel with the 35 kilowatts electric motor had A. 15% better acceleration, B. 15% shorter distance to stop, C. 25% more pulling power, D. Up to 20% more thrust at 4.5 knots speed in adverse weather conditions, E. At 6 knots cruising speed a reduction of over 50% of fuel aka electric energy consumption. F. The motor was always in best load condition, where the combustion engine would suffer from a light load problem. The vessel equipped with the electric motor achieved 8.3 knots, which equals 95% of the theoretical max hull speed by using only 26 kilowatts, 8 knots by using only 17.7 kilowatts, and by 6 knots by using only 5.77 kilowatts. In comparison, the vessel equipped with the 55 kilowatts diesel engine had a fuel consumption of 0.43 gallons per hour at 6 knots, but at 8 knots the consumption was 2.14 gallons per hour, which means 5 times as much. At this point it needs also be emphasized that with a conventional reciprocating engine there are problems, when the engine is not operating in its best operating envelope. If at 6 knots the required poker is only 5.77 kilowatts, the engine is operating far below the best operating range. The engine with 55 kilowatts rated power is used by only less than 11% of its potential power output. Other facts to consider. The weight of a diesel engine including the fuel tank, is considerably higher than the electric motor including battery bank. No fuel smells. No engine noises. Far less maintenance. No through holes for cooling, if a direct drive pod motor is used. Recharging option if cruising under sail. If used with a PV system and inverter charger, no cost for fuel aka electricity. While you can recharge your battery bank with an electric drive while cruising under sail, you can't put fuel back in your tank with your diesel drivetrain. Given these facts and findings, there can be no doubt that the future of vessel propulsion at various levels is electric or hybrid electric, as it slashes maintenance and operating costs in many ways. If you liked this episode, and want to get more information of this kind, please like, subscribe and hit the bell button, in order to not miss future episodes. Also, if you have questions, please leave your questions in the comments, I will try to answer them as swiftly as possible.